luminous objects. Luminous objects. The objects which can produce their own light or emit their own light are called as luminous objects. Luminous objects are of two types: man-made luminous objects and natural luminous objects. Natural luminous objects examples are sun, stars, fireflies, and etc. And man-made luminous objects are candle, torchlight, bulb, tubelight, and etc. Non-luminous objects. Non-luminous objects are the objects which cannot produce or emit their own light. They are visible whenever the light falls on them. For example, table, chair, bulb, book, and etc. Based on the amount of light passing through them, the objects are of three types. First one is transparent objects. Transparent objects are the objects which allow complete light to pass through them. For example, pure water, pure glass, and etc. Can you see the light through this?
Yes.
So, this is a transparent object. Can you see my hand clearly?
Yes.
Yes. So, this is a transparent object.
Very good.
The next object is translucent. Translucent objects are the objects which allow partial amount of light to pass through them. For example, butter paper, wax paper, oil paper, and smoked glass, and etc. Can you see the light completely like transparent objects? No.
No.
You cannot see complete light.
Yes.
But you can see some amount of light.
Okay.
So this is a translucent objects.
Very good.
And can you see my hand completely?
No.
You cannot see. So this is a translucent object. And next one is opaque objects. Opaque objects are the objects which doesn't allow light to pass through them. For example, wood block, doll, pencil, and etc. Can you see the light to this?
No.
You cannot see. Can you see my hand?
No.
You cannot see. So this is a opaque object. Propagation of light. The movement of light is called as propagation of light. This light from the sun reaches our earth in 8 minutes 20 seconds. By this we can understand that light travels very fast. The straight line on which the propagation of light energy takes place is called as a ray. The group of such rays is called as a beam. There are three types of beams: parallel, convergent, and divergent beams. First, parallel beams. Here I made a model by using slipper and pencils. Imagine these pencils as rays. First one is parallel beam. Here the rays are straight. So this is a parallel beam. Next, convergent beam. Here all the rays start at different points and meet at same point. So this is a convergent beam. And next, divergent beam. Here all rays start at single point and goes in different directions. So this is a divergent beam. Let me explain you parallel, convergent, and divergent beam by using this activity. You can see a beam here. This is parallel beam. This is convergent beam. And this is divergent beam. Light travels in a straight line. Let me explain you this by using these three activities. See, here I kept this series in a straight line and the candle is source of light. Can you see the light to this series? Can you see the light through this series?
Yes.
Yes.
So by this we can say that light travels in a straight line. Now can you see?
No.
Because you cannot see the candle light because I blocked this light.
Okay.
And now next activity. See, you see the candle light by using this straight straw.
Yeah, I can see. I can see.
You can see the candle light because this straw is straight. And see by using this bent straw. Can
No,
you see?
I can't see the light from this.
You cannot see the light from this because this straw is not straight. And next, so this is a laser pointer. See, you can see that here light is this laser light is traveling in a straight line. Let me explain you about the shadow. Shadow is formed when the path of the light is blocked. See here, the path of this dark light is blocked by this object. So here, shadow is formed. So, however, the object is colorful, but the shadow is always in black color. When there is a change in the position of a light source, object or screen, we can see the change in the size of shadow. In first condition, the screen and the object position is fixed and only the light source moves. When the light source comes near, then the shadow of the object becomes bigger, and when the light source goes far, the shadow of the object becomes smaller. In second condition, there is a fixed position of screen and light source, only object moves. When the object comes near to the screen, it becomes smaller, shadow becomes smaller. And when it goes far to the screen and comes near to the light source, the shadow of the objects become bigger. In third condition, the position of light source and the opaque object is fixed and only the screen moves. When the screen is near to the object, the shadow is smaller.
Oh.
And when the screen is far to the opaque object, then shadow is bigger. Different parts of shadow. This is the object, this is the screen, and this is the light source. There are two parts of shadow. Those are umbra and penumbra. Umbra is the darkest part of the shadow, and penumbra is the lightest part of shadow. Eclipses. Eclipses are formed of the result of formation of shadow of the earth or moon. See here, by using this model, I am going to explain you about the solar eclipse and lunar eclipse. Here, this candle is the sun, the small ball is the moon, and this big ball is the earth. So first, solar eclipse. Solar eclipse is formed when the moon is present between the sun and the earth. Then we cannot see the sun because the shadow of the moon is falls on the earth. And next one is lunar eclipse. The lunar eclipse is formed when earth is present between the moon and the sun. Then on this day we cannot see the moon because the shadow of the earth falls on the moon. Let me explain incident ray and reflected ray by using this activity. This is a plate mirror and this is the laser light. This ray is the incident ray, and the ray which is reflected here, that is the reflected ray. Let's see the reflection in the convex and concave mirrors. This is the concave mirror and this is the convex mirror. Here in the concave mirror, the reflection is like this, and in the convex mirror, the reflection is like this. Reflection. The bouncing back of light is called as the reflection. There are two types of reflections: regular reflection and irregular reflection. I am going to explain you this by using this model. Here we can see the beam. Now I will explain you the regular and irregular reflections. See here. This is a plane mirror. Here you can see that the incident ray and the reflected ray are parallel. And this is a irregular mirror. Here you can see that the incident ray and the reflected ray are different, are not parallel. Now let me explain you about the angle of incidence and the angle of reflection by using this model. See, this is the angle of incidence and this is the angle of reflection. By these two models, we can also explain reflection. See. Let me explain you about the lateral inversion. Lateral inversion means left to the right, right to the left. Now here when I lift my right hand, in mirror we can see that my image showed left hand. Refraction. Refraction means the bending of light is called as refraction. See here. Pinhole camera. This is a pinhole camera. For making this, I used butter paper, black paper, cardboard, and also I kept a small hole over here. There is no lens in this pinhole camera, but it shows inverted image. Can you see the inverted image of this candle light?
Yes.